Okay, next let's look at winter 2016 number 2. Here we have an 8-foot length of wire, and we want to make a square and a triangle out of it so that we have the minimum possible area of the two shapes. Okay, so we want the area, this area here, area 1, this area here, area 2 to be, add them together to be the smallest possible area. And so this is a square, so call one side x, the other side's x. So the area is obviously x squared, right? So the A1 is x squared. This one's a little bit tricky if you just read it. But he says how one leg of the triangle is 3/4 of the other leg. So this leg, and you know, if they didn't have the answers, it's kind of confusing. I could see where a lot of people mess this up, but they should have just said it's a 3, 4, 5 triangle. That would have been an easier way to say it. But anyway, you can see legs means not hypotenuse, which again is kind of confusing. But this leg here is 3/4 that leg. So if we call the number of units the length y, so this one is 3y, that would be 4y, because divide them we get 3/4. So would it be y is a number of units. If this one's 3y units, this one's 4y, which makes that 5 because it's a 3, 4, 5 triangle, right triangle. Yes, then this is a right triangle, they said. So that's kind of confusing. But the point is we have to call the dimensions something. Call this x, and we don't have to call this y, but they did in the solution, so I'm going to use y too. So this area is x squared. This area is 1/2 base times height. A2 is 1/2 base times height, which is 1/2, the base is 4y, and the height is 3y. So that's half of 4 is 2, so that's 6, so 6y squared. And we want to minimize these things, okay? So the total area is x squared plus 6y squared, and we want that to be as small as possible. Now the other thing we know is we have 8 feet of wire. So the perimeters have to add up to 8 feet. So the perimeter, our square perimeter, there's 4 x's, so that's 4x. And this one is 3y plus 4y plus 5y, which is 7 plus 5, 12y, right? 9, yes, 12y. 12y, and that's got to be 8 feet. So we just know we're dealing with feet here, so I'm just going to write 8. Now, what we can do is solve for, it doesn't matter which one, solve for x or y, and plug it into the other equation. So, and then we have just one of the variables. Doesn't matter which one we do. And the answers they solved for, I think they solved for x, and then they plugged it in here for x squared. So we might as well do that too. So let's see, first we can divide this whole thing by 4. So x plus 12 divided by 4 is 3, 8 divided by 4 is 2. Okay. And then we want to solve for x, so x is equal to 2 minus 3y, and actually we need x squared. So x squared is equal to this one squared, 4, plus this one squared, that's 9y squared, minus 2 times them multiplied together. 2 times 3 is 6, so that'd be 12, right? So minus 12y. So multiply together we get 6y, and there's 2 of those because of cross terms, minus 12y. Okay, that's what x squared is. So now we plug that into here. So our area is x squared, so this 4 plus 9y squared plus, minus 12y. Okay, I'll put this here. Plus 6y squared minus 12y. Okay, 4 plus 9y squared minus 12y from down here, and then the 6y squared from up here. Okay, we can add the y squareds together. So our area is, let's put the y squareds first, 15y squareds minus 12y plus 4. Now, notice that is a parabola. That's a quadratic. It's positive. A is positive, so we know it opens up. And we can figure out b, the bottom here, the x value of the b, sorry, not the x, but it's just negative b over 2a, right? So this value here, the x value there, is negative b over 2a, and that is the point where it's the smallest. And because it opens up, we know we're going to be getting the smallest part. If it was the other one, we'd be getting the biggest area possible. But we know that the way this works, we're going to get the smallest area possible. Okay, so we just need to go negative b over 2a to find what the y value is. Actually, this is y. We're finding a y value there, so that should be a y. So what y value for this parabola gives us the smallest value? It's negative b over 2a, so b is negative 12. So that'd be 12 divided by 2a. A is 15, so 2 times 15. It's negative, okay, so that's 12 over 30. Let's see, you can both divide those both by 6, right? So that's 2/5. Or, we'll just write a decimal, 0.4. So y is 0.4, and therefore x is 2 minus 3y, so that's y, right? So x is 2 minus 3y. So that's 2 minus 3 times 0.4. 3 times 4 is 1.2. 2 minus 1.2, which is 0.8. 0.8. Okay, so now we know the dimensions of our triangles. So x is 0.8 and y is 0.4. So what is the biggest area? So our area is x squared plus 6y squared. So the biggest, our smallest area, this we find the smallest area. So the area is x squared plus 6y squared, or we could have just plugged in y. We didn't have to figure out x. We could have just used this and plugged in our y. Or we could use, I figured out x just because why not? It's kind of fun to know how big the square is. We didn't have to do it this way, but I already did, so what the heck. So again, all we needed was the y value to plug in here. But I'm going to do it this way. So x squared is 0.8 squared plus 6 times y squared, 0.4 squared. Let's see, that's 0.8 squared is 64, so 0.64 plus 0.4 squared is 16, so 0.16 times 6 times 6, 0.96. So 0.96 plus 0.64, and that is 1.6. So the answer is 1.6, and we're dealing with feet here, so that's feet squared. So 1.6 square feet is the smallest area we can get. And again, we know it's smallest because our parabola opens up. So the point down here for this formula gives us the smallest value. So, okay, so the point here is to find the smallest. We know we're going to get a parabola, and then we just use the negative b over 2a to find that point in the parabola. Because otherwise, to find the smallest, there has to be a smallest, has to be a minimum like that. Which means pretty much a parabola. Anything that just keeps going up, or a straight line or something, won't have a minimum. So, okay, good. Thanks for listening.